Alright, you guys, today we are going to be learning about the line of best fit. So your essential question for today is, what is a line of best fit and how do I utilize it to predict the future values? So a line of best fit is actually a trend line that is placed as close to the middle of the data as possible and provides a way to calculate or estimate a future value in that data set. So for example, if we see that we have our dot plot here, we have all of our dots that are kind of all scattered all over the place. Our line of best fit is this line right here that is right in the middle of our data, trying to hit as many points as we possibly can, and this is our actual line of best fit. You guys might also notice that it's also called a trend line, so line of best fit, or it's also called a trend line. So those are the two names to help us determine what this actually is. Okay. And now, in order to calculate the line of best fit, this is going to be by hand. So if we are calculating the line of best fit, this is actually an estimate. So make sure that you know that it's just going to be an estimate of what our linear regression line will actually look like. So the steps in order to do that, you're going to identify 2 points. And those 2 points can be from a table, a graph, or a list. And then you're going to determine the slope by using those 2 points. And remember, it's your y2 minus y1 divided by x2 minus x1. Okay? So once you have determined the slope, you are then going to determine the y-intercept which is the b value, by using one of the points that you actually picked. And then you're going to determine you're using your new slope that you just found from step 2. And then you're going to isolate b, or you're getting b by itself. Once you have b by itself, you're going to rewrite the equation so that it is in your slope-intercept form of y equals mx plus b. And then our next thing, calculating future values using a line of best fit. So we are using this to help us predict other values. So the steps of doing that: identify what x and y represent. So in our example, I will be identifying it and showing you guys in a second. And then step number 2, you're going to substitute a value for x and for your y. Then you're going to solve for the remaining value. So let's actually do an example here. So if you see, the example is by hand. So we're going to create a scatter plot and determine the line of best fit and the strength of that correlation. So the correlation was our previous set of notes. So for our x, that equals the number of months. So this is identifying what our x and y's represent. So x is our number of months, and then our y is the money that is actually in our bank account. So money in account. So now, this is actually a list of numbers. So this is where I'll be pulling my 2 nice points from when I actually calculate this by hand. So we're going to go ahead and plot these points first. So when I do this, I have 2, remember this is my x, this is my y. I'm going to go to the right 2 and then go up to 100. So see how this is 1, so this is going to count as 100, and then 200, and so on. So I'm at 2, and I'm going to go up to 100. Then I'm at 3, and I'm going to go up to 120, so it's going to be a little bit lower than the 200. And then 4 is at 150, so we should be in the middle. It's okay if they're not exact, you guys. 5 is at 200. And then 6 is almost a little bit at 190. Okay, so there's our dot plot there. So now we are going to draw a line of best fit, and that line of best fit, when we're trying to hit as many data points as we can. So if we are going through there, we hit as many points as we possibly can, which we hit kind of most of them. You have to have a straight line though. So once you have a straight line, we are now going to calculate our line of best fit. We're going to take 2 points. So I'm just going to take my first point, 2 and 100. And then I'm going to take another point. You guys could totally use other points here. So I'm just going to take this one, and I'm going to take 5 and 200, just so I could show you guys why I'm using 2 different values. Because if you take different values, you will get different numbers. We're going to label these x1, y1, x2, y2. I'm going to use my slope formula, so I have 200, y2 minus y1, and x2 minus x1. If I get that, I get 100 divided by 3, which ends up giving me 3.333 and continues on. So we're just going to use 3.33. And then now I'm going to take a point, and it could be anyone that you want. I would just choose one of them. We're going to plug that into our y equals mx plus b equation. So our y equals 100. Our new slope is the 33.33. Our x value that is 2, the point that I circled, and then we have plus b. So now I'm going to do 2 times the 33.33, and I get 66.66 equals 100 plus b. We're going to subtract the 66 from both sides, 0.66. So 100 minus 66.66, I end up getting 33.34. And that is my b value. Okay, so the important information here that I want to actually use is my b value and my m value. So now I'm going to rewrite my actual line of best fit here. I'm going to rewrite it down here. Hopefully you guys have enough room. So I have y equals 33.33 x plus my b value of 33.34. So wow, we are pretty close to having this. So this is our linear regression line. So it should be positive because we have a positive line going up. And then now our correlation. So how strong does it actually hit those points? And is it pretty close? So we would take an average, because if you guys look at your previous notes, the closer the lines are together, the stronger the correlation, but it's probably not exactly, because we do have this one little outlier here. So our correlation here, if we kind of estimate it, I'd say it's about 0.95, which means that we actually have a strong positive correlation. And remember, that's our correlation coefficient that we just determined. So our strong positive correlation, so this would be our R equals 0.95. We're just kind of doing a rough estimate of it because remember, finding it by hand is an estimate. And then that, since it is a positive, your slope and your correlation coefficient should both be positive because it is a positive line going up. We will be going over this example by a calculator, so it's the same example, but we're going to be using a calculator, and we will be doing this in class tomorrow. So I will see you guys in class, and have a good day.